Okay, so this is my assessment piece for EDUC 2059, assessment 2. Okay, so the first part of this particular, we'll be looking at the prior knowledge lesson. We'll be doing a carousel brainstorming activity. The time it will take will normally be around 40 to 50, 45 minutes, which is normally how long a normal lesson goes for. The key mathematic components that will be looked at will include area, length, perimeter, shapes, circumference, volume, and capacity. The key aspects of thinking and working mathematically that will be developed in our children, that obviously will be in the class, will be the understanding of the key aspects of what will be taught and learned in the lessons coming up, and an understanding of what each of the students' prior knowledge and skills are, of the different sub-genres of the topics will be. The key initiative skills that will be looked at as well will be that the teacher will get students to get them to express their ideas, their own previously gained knowledge with their fellow students, and be able to get them to talk to you about what they will learn about and what they are interested in. So the lesson will go something like this. Around the classroom there will be an area where the teacher will place 6 different stations / checkpoints, with each of these checkpoints, 5 different stations, these checkpoints covering 5 areas of the mathematical area of geometry and measurement. We have length, area, perimeter, shapes, volume, and capacity. That's 6. The teacher, to start engaging the students with the learning activity, will get the students to rotate around these stations for a designated amount of time. For this task, students will be travelling in small groups. While doing this, while at each of the stations, students will be asked to activate their prior knowledge of the different areas / topics / aspects of the topic at hand through conversation in their groups. Ideas they have thought up in the group will be posted at each of these stations for other groups to read and obviously get an understanding of what their fellow students are talking about. Through conversation and movement, their prior knowledge will obviously be activated, providing scaffolding for new information to be learned in the preceding lesson activity. So the procedural lesson for the teacher to obviously partake in will be that they will generate a good amount of questions for the topic and write each of these questions on a separate piece of paper / whiteboard, etc. Any sort of surface in which they can obviously write something would be good. With each of these questions to be posted around the classroom, groups of students should be looking, groups of the groups they're in should be around 6 or so students. With this example coming from the fact that if the classroom normally has about 30 students in it, there would normally mean to be about 6 groups, there'd be 6 groups of 5 in it for this lesson to run smoothly. Direct each of these groups to stand in front of their first station, so starting point. Give them each of the groups a coloured texter to write down ideas at each station, with the teacher using each coloured texter to track each group's progress. Inform each of the groups that it will have a certain amount of minutes, which will be around 4 to 5 minutes, to go from obviously checkpoint to checkpoint. When the time is over with at one particular checkpoint, get them to rotate in a clockwise direction. Numbering, the teacher would obviously number each station, make sure that students understand the way in which they will need to go. By using a stopwatch or some other form of calculating time, they will obviously get that down pat. Throughout this go around, the teacher obviously go around and ask random groups of what they are thinking about when discussing what they could possibly answer the question at hand about. Obviously give them feedback, a little bit of feedback, but if you feel like you're not going the right direction, they aren't going the right direction, obviously you help them out and make sure they can get back on track. Have each of these groups select their top 3 ideas from each of the stations they have thought about and share them with them and the rest of the class. Obviously get one person to nominate themselves and obviously stand up in front of the class and say, this is what we thought, These are our ideas, and obviously your fellow students from the different groups will obviously provide them feedback. This will close their experience of the lesson. The learning experience that may follow would focus on some of the following topics: length, area, perimeter for our first lesson, which we'll talk about later. The second lesson will consist of shapes, the area of different types of shapes as well, and volume and capacity, and how that fits into mass. Oh, and perimeter as well, sorry. Teacher and student resources. The key teacher resources that will support planning, description of how they'll be used in the classroom will be that obviously a teacher will have to know and have a knowledge and understanding of the topic, which they'll use to engage students and get them to think about what they could put down when doing the activity. The classroom, obviously the environment / workplace in which they have created, which students feel comfortable and ready to learn. Stations, using tables and other previous equipment that's in their classroom they can use to create stations, and the necessity to get paper, obviously, to give these students something to write an answer down on, an answer being that they think it's the right answer, and obviously that's what they think. Obviously reiterate that everyone will have a different sort of opinion on what each of the station's questions will be. Text is obviously coloured to know which group is going to write down their ideas. A whiteboard is obviously record the 3 main ideas given by each group, and obviously you can go over that and say why did you think this and all that sort of stuff. That's the key learner resources for the student. Obviously is just their prior knowledge, a texter they will use at stations, and a notepad to jot down ideas in their group. Links with Australian curriculum. Obviously strand mathematics, substrand year 5 measurement and geometry, location and transformation, and these are substrands, location, transformation, and geometric reasoning. Obviously students will have to choose appropriate units of measurement for length, area, volume, capacity, and mass. They'll obviously calculate the perimeter and area of rectangles using familiar metric units. Describe translation, reflection, and rotation of 2-dimensional objects. Identify and align rotational symmetries. That's something they will get into later on in the unit, obviously, because we're just focusing on area. The main topic of area, in the lessons coming up, I'll talk about. Apply the enlargement transformation to maintain 2-dimensional shapes and explore the properties of the resulting image compared to the original. That's something we'll also look at. Estimate measurement and compare angles using degrees. Construct angles using a protractor. Those last 3, obviously, something the teacher could focus on later on, after obviously going through area, perimeter, and all that, because they're all very closely linked. And there's all something that the teacher could obviously bring into later on. Links with early years learning foundation, whatever framework. Outcome 4: children are confident and involved learners. Children resource their own learning through connecting with people, places, technology, and natural and processed materials. Alright, so here's a breakdown of how I want to do my lesson. For the first lesson, we'll be looking at the mathematical areas of length, area, and perimeter. We'll start with length and look at the key areas of length, the unit measurement, the estimation of the measurement, the actual measured length of the object that's being measured. For an activity idea, students will get to create their own units of measurement and use that obviously to measure things, which the teacher will obviously help them with to create an idea if they feel that the idea that the student has learned, that has been using, is obviously a bit far-fetched. We will then move on to area and perimeter. So we're talking about the different shapes and how that use models of area units, measuring surfaces, the multiplication factors of areas and triangles, and the sort of strategies we can use, how we can look at the relationship between area and perimeter, and the misconceptions that students get from what each one is compared to the other. We'll develop activities around getting students to have a deeper understanding of the relationship between area and perimeter, particularly looking at rectangles. We'll develop formulas with the main formula idea that is length of the base times the height. This is all in my part 2. Make sure students know the difference between the two, and that's what the first lesson will be about. Second lesson will be about looking at area of different shapes, particularly rectangle, parallelograms, triangles, and how we can create conceptual formulas for the students to use. They will create their own conceptual formulas to use, but obviously the teacher will obviously give them a formula in which they can use that is well known. But obviously students will have to create their own idea of how they can use that formula and how they can create their own understanding of it. After going through triangles, parallelograms, rectangles, find out all the area for that, we'll move on to volume and capacity. We will look at how the capacity of containers, the volume of cylinders, prisms, all that sort of stuff. That is all in my part 2. And after completing these 2 lessons, students obviously have a lot of knowledge in their head, and the teacher will obviously want to revise their knowledge and get them to look at the formulas and how they feel about it. We obviously want to get them to create their own understanding of the work that they're doing, and not just have one singular idea of what the formula must be. And obviously we'll get them to look at how they have created these formulas and what their fellow peers think of them, and if they have the same sort of ideas. So yeah.